right, nomenclature. Everything has a naming system. If you're sailing or playing basketball, there's a naming system for everything. So there's systemic name, which are usually very long, and they describe structure. Generic name, think over the counter like ibuprofen. You can buy that. There you go. And then there's the trade name, which is what a company decides to call something. So in medicine, there's a lot. All right. So you have your NSAIDs, opiates, schedule 1 through 5, contraceptives, blood derivatives, vitamin, muscle relaxers. And these are just some. So we have to classify things here. So you might think of like a generic name like alprazolam. That trade name is Xanax, but its systemic name is 8-chloro-1-methyl-6-phenyl 4-HS triazolo 4,3-alpha 1,4-benzodiazepine. That's a mouthful, but this tells us the structure. These are what they're kind of known as. So we have to start getting into a naming system. This next slide, slide 6, you have to memorize this. You will memorize this. It's this. These prefixes are going to tell us how many carbons there are. Meth, eth, prop, bute, and then it's sort of geometric. Pent, hex, hept, oct, non, dec. You won't have to go bigger than 10, but these you got to know. So prefix are what and where things are. Got it? Parent, what's the longest carbon chain? These things right here are your parent names. Your suffix, what is the functional group? And it's always ane for alkanes, right? So I said ethane, 2 carbons, F. Ane means there's a single bond between them. So here we go. All right. So this is right here in systemic way of naming. There's the prefix, the parent, and the suffix. Yeah. So octane, there is no prefix. That's possible. Oct, there's 8 carbons. See, 8 carbons right there. Oct. Ane, only single bonds between carbons. Since carbons have to make 4 bonds, we have this between all of these carbons. They're single bonds, which means each of them has to be filled in with hydrogen. This first one needs 3 of them, then 2, 2, 2, 2, 2, and then 3. There you go. Methane, 1 carbon, 4 hydrogens because it needs 4 bonds. Propane, 3 carbons. And if we think about propane, there's a carbon, carbon, carbon. All right, they're all singly bound, which means the one on the ends needs 3 hydrogens to fill up those bonds, and the one in the middle needs 2. We have a grand total of 8. And that's how this works. There's carbon substituents. All right, these are for branched alkanes. All right, and so I'm going to walk you through these. So here we go. Substituents are things bound to the main carbon chain. Some of these can be comprised of only C and H. There's a methyl group. See, there's only 1 carbon. Ethyl group, 2 carbons. Propyl, butyl, pentyl, hexyl. You understand this. So 2-methylhexane. Okay. This 2 means that on carbon number 2, there's a methyl group. There's hexane. Got it? So our main chain is hex. 1, 2, 3, 4, 5, 6. There's 6 carbons in a row. We can start counting on either end. It doesn't matter. But here in the black one, I said carbon number 2, see 2-methyl, there's a methyl group coming off. On the blue one, we started counting on the right, just because. So this is 1, this is our carbon number 2. There's a methyl group. Both are correct. Got it? 2,4-dimethylhexane. Well, we got our hexanes again. Di means 2, so there's 2 methyl groups on carbon number 2 and carbon number 4. Here, carbon number 2, carbon number 4. What's important to note about this guy right there is that carbon needs to make 4 bonds. It's got 1 bond there, 1 bond there, 1 bond there, and that 4th bond is going to be to this hydrogen. All right, so that's how we do branched. Here we go, 4-ethyl-2,5-dimethyl-octane. That's a bit of a mouthful. The group that goes first is strictly alphabetical. That's why I put ethyl first. That's the only reason. So here, we have octane. That's our parent. That's the whole spiel. So 2, 3, 4, 5, 6, 7, 8. There's our 8. And for this black one, I started counting here. 1, 2, 3, 4. There's our ethyl group, 2 carbons. Then 2 and 5 has methyl groups. If you look over here, 2 and 5 have methyl groups. This is our ethyl group on number 4.